this question here. Like I mentioned, you need to be on the lookout from this day forward anytime you're doing a derivative for chain rule. So practice one is asking really which of the following does not require the use of the chain rule. So again, circle the terms that require the chain rule. So go ahead and take a look at these four. There could be more than one choice or maybe just one. But go ahead and see out of these four if you can recognize which one of these would require the chain rule. So which one of these would you think? It could have more than one answer. Would we have to use the chain rule on A? Yes. What about B? No. What about C? Yes. What about D? Hearing a yes, I'm hearing a no. A wait. No. Okay. Like I said, just make sure you recognize when you have to use the chain rule and when you don't. Questions on why any of those we use the chain rule versus when we don't. So here's a table. We talked about the derivatives of inverse functions and the derivatives last class. So they're telling you the table is representing function f. So they're giving us the values for f of x and f prime. Then they're telling us that we have this other function g of x. And again, notice they're defining g of x as this f of x plus f of 2x. So we have no idea what g of x is. And again, they're giving us that g of 3 is equal to f of 3 plus f of 6, which is equal to 9. So basically what they're saying is that we know that, of course, g of 3 is equal to 9. And you can see that from the table. F of 3 plus f of 6 does indeed equal 9. Which of the following describes the process for finding the inverse of g derivative of 9? So again, take a look at this notation. Don't let this notation scare you. Remember that -1 exponent that you see, that simply means that's your inverse. So we're talking about the inverse of g. This hash mark here, we're looking at the derivative. Yes.
Can I get another?
Let's see if I have any more. Like I mentioned the other day, anytime you're talking about derivatives and inverse, build your table. We talked about that little table. That half the time will get you to where you need to be. So again, the process for finding the inverse for g's derivative. So again, I'm trying to figure out what is my inverse for g's derivative of 9. So I know that this comes from some point. So my inverse for function g of 9 is equal to something. So the inverse of g, then remember the x and y switch. So g of something has to be equal to 9. What is that x value there? 3. So then g prime of 3. If I know g prime of 3, I know I can find the value of the derivative for the inverse of g. So any questions so far on how I filled out this table? So now remember they gave me g of x. They gave me g of x as f of x plus f of 2x. So I can find g prime of x. So g prime of x can be found by taking f prime of x plus what rule am I going to have to use to find the derivative of f of 2x? I'm going to have to apply my what? Chain rule. So f prime of 2x times 2. Then, of course, I can find g prime of 3 by plugging in a 3 for x. So g prime of 3 is equal to f prime of 3 plus f prime of 6 times 2. So this is what I would need to do. That would help me find. And then, of course, I know if I can find g prime of 3, it's a matter of taking the reciprocal to find the value of the derivative of the inverse. So now in your 4 answer choices, if you notice, they're giving you the formula to calculate G prime of 3. There is only one out of these answer choices that has the correct way to calculate G prime of 3. Which answer choice would it be? There's only one. Which one is it? C. There's the only one. So again, if you look right here, that's the only one that matches the formula that we came up with. Again, what this is telling you, remember, you're taking the reciprocal, which is the relationship between what the derivative's inverse is and its inverse. So any questions? So it can't be any others. Okay. And again, the reason why it can't be B is because you're not taking the reciprocal, that inverse, in case some of you thought it was B, because you didn't take the reciprocal. So any questions on that one? So that's sometimes just a little twist they may ask you about derivatives of inverses and their derivatives. So then like I said, we're not learning any more rules. It's just different wording that they may throw at you when it comes to this concepts we talked about in this particular unit. So take a look at practice 3. Which of the following could be used to find the slope of the tangent line? So again, when we talk about the slope of the tangent line, what are we actually calculating? We're actually calculating the derivative. So again, we're actually looking at which one of these could actually calculate the derivative. Take a look at tangent of 2. Is that a constant? Or would I have to do that 1 over 1 plus x squared? Versus inverse tangent of 2, is that a constant? Yes, it is a constant. It is a constant. We don't know what it is, but it's not a variable, it's a constant. So when I take the derivative of that inverse tangent of 2, that's just simply going to go to what? 0. So see if you can find out which one of these would be the correct answer choice. So when I came up with a derivative, this is what I came up with. Don't forget to use that chain rule inside of that inverse tangent. So which is going to be the correct answer choice? D. Be careful about C. How come it's not C? No squared. So just be careful about that. Sometimes they'll try and trip you. They'll leave a little thing off like that. Questions on that example? Okay, so now let's just talk about higher order derivatives. So again, we've looked at the second derivative, we've looked at the first derivative, but obviously there are higher derivatives out there. Again, just a reminder, some notation for first derivative. Here's your dy dx. You may see that f prime of x. Those are your common derivative notations that we see. You also have that d over dx as well. All notation, or you may see that uppercase d of x, d sub x. So then to indicate the notation for the second derivative, if you're using the notation dy dx, you'll see this exponent d2y over dx squared. So that's the notation you may see to indicate the second derivative. If you're using the prime notation, you may see the 2 hash marks f double prime of x. So you may see that to represent the second derivative. And then you can see you have those upper indexes with those other notations to indicate the second derivative. So if you're looking at the third derivative, again, you would just simply see this upper index to be a 3, the d3y over dx to the third. The third derivative of y with respect to x. Again, you would see, if you're using the prime notation, you would see the 3 hash marks there. So just the way you can indicate how you can recognize which derivative. There eventually reaches a point when, especially if you're using that prime notation, they're not going to write out 4 hash marks. So what you'll see commonly is you'll see your f and then the actual numerical index. So for example, if you want the fourth derivative, you would see that upper index to be a 4. So again, if you're talking about the nth derivative, you would see that f upper index of n. Whatever derivative was a fifth derivative, you would see f to the 5th. So let's take a look, because I want to definitely do the calculator question with you. So let's take a look at example B. Which derivative are they asking me to find in letter B? Third. You can't get to the third derivative without getting to the second derivative. You can't get to the second derivative without finding the first derivative. So you've got to just start with the first derivative and progress sequentially. Again, I know that 1 over x is equivalent to x to the negative first. So then to find my first derivative, again, I can use the power rule to find the derivative of x to the negative first. So that's going to be negative x to the negative second. And I'm not going to rewrite it with positive exponents because I know I have to calculate 2 more derivatives. So any questions how I found the first derivative? So now I'm going to find my second derivative. Again, I'm going to use my power rule again. So negative 1 times negative 2 is a 2, x to the negative third. And then finally, I'll find my third derivative using my power rule again. That's going to be negative 6x to the negative fourth. Or if I write this with a positive exponent, negative 6 over x to the fourth. Now, what's that subscript right there asking you to do when you see that x equals 1? What's that asking you to do? Plug in 1 into the third derivative. So then to find the third derivative at x equals 1, I'm simply going to plug it in for x. So negative 6 over 1 to the fourth is negative 6. So remember that little, just like, so if you see that subscript, you're simply finding the value of that, whatever derivative they're asking you for. So let's take a look at the practice 4a. Which derivative are they asking me to find? Second. Now let's talk about this 5e to the third. Is it a constant or is it an exponential? Constant. It's just a numerical. So when I find my first derivative, so what happens with the derivative of 5e to the third? 0. Now notice you've got this e to the negative 2x. That's not a constant. Does everybody see the difference on why it's not a constant? What rule are we going to have to use to find that derivative? We're going to have to use the chain rule. So that's going to be my e to the 2x times 2. Take the derivative of natural log of 3x. Remember, that's going to be a chain rule as well. It's going to be 1 over 3x times 3. And then what happens with the derivative of negative 10? 0. So any questions how I found the first derivative? Now, when you are finding higher order derivatives, you want to simplify and you want to clean up your derivative as much as you can before you take the derivative of a derivative. So this first derivative then, when I clean this up, is going to be this negative 2e to the 2x. And then 1 over 3x times 3 is just a 1 over x. So before you take another derivative, make sure you clean up and you simplify as much as you can your derivatives to make the differentiation process a lot easier. So go ahead and find the second derivative for me. So any questions, like I said, on finding your second, third derivatives if you need to, okay? Again, spiraling back in some vocabulary we looked at back in unit 2. So they're asking us to find the instantaneous rate of change. Remind me again, what does that instantaneous rate of change actually mean? What are we going to find? We're going to find the derivative. So we're going to find the derivative. Now, be careful and make sure you read very carefully. They're asking us to find the instantaneous rate of change of which particular function. It's not of f, but it's of what? F prime. So if they wanted me to find, and what we did back in unit 2 was we found the instantaneous rate of change of f, which means we found the first derivative. If I want to find the instantaneous rate of change of f prime, what derivative do you think we're going to find? The second, and then we're going to evaluate it at x equals 1. So be careful, make sure you know which derivative they're actually asking you to find if they're using that vocabulary instantaneous rate of change. So we want to find f double prime of x and evaluate it at 1. So any questions on why it's the second derivative that I'm going to plug 1 into? what rule, what's happening between x and natural log of 2x? What operation's happening there? Multiplication. So I'm going to have to apply my what? Product rule. So again, I've got my f, which is x, my g, which is the natural log of 2x. I know the derivative of x is 1. What's the derivative of natural log of 2x? It's going to be 1 over 2x times what? 2, which is just 1 over x. So then to find my f prime of x, I'm going to plug it into my product rule, remember, which is my f prime g plus f g prime. So f prime is 1 times g, which is the natural log of 2x, plus f, which is x, times the natural log, times my g prime, which is just 1 over x. Again, simplify this as much as you can. So this is going to be natural log of 2x plus 1. So any questions on how I found the first derivative? So go ahead and finish that for me. Find the second derivative and then evaluate it at x equals 1. Did everybody come up with a 1? Okay. Read practice 5. We're not going to do that because I'm going to do a couple calculator things with you. Which derivative in practice 5 would we be finding? Second, because the instantaneous rate of change of f prime. So we would be finding the second derivative and evaluating it at pi over 3. All right. So any questions on, again, when you find the instantaneous rate of change? Okay, everybody take out your calculators. Let's take a look at a calculator problem. It's been a while since we've done some stuff with our calculators.
Thank you.
Okay, so here's our table question. Notice our table is giving us values for function g. So function g is from the table, so we have values of g of x and g prime of x. Always read the information they're giving you in the first sentence or two. Notice they're also giving you an f of 3 is equal to 2. And then they're talking about a completely different function, but they're not giving us f of x. They're giving us f prime of x. So make sure you pay attention to which exact function they're asking me about. Is it f or is it g? So look at part A. So part A is asking me to find f double prime of 2. So again, remember, this is a calculator question, so you should not be doing any work by hand. Because remember, your calculator, sine of 2 is just a constant. So I can plug and chug into my calculator, let my calculator do this work for me. So remember how we can find the value of the derivative using your calculator. Again, go to your y equals. So it's asking me to find the second derivative. So I can plug in the first derivative under y1, which is given to me as x times the cosine of e to the x. And again, remember, e is under that second ln. Oops, let me backspace there. Remember, in calculus, anytime you are dealing with trig and calculus, double check your mode. You always want to make sure your mode is in radians. Calculus and trig, it's always radians. Go back to your home screen. So now, again, under your alpha window, you can select option number 3, which is that n derivative. That will calculate the derivative for you. We're always doing the derivative with respect to x, so I'll select an x in that denominator. Calculator is now waiting. What do you want me to find the derivative of? Well, we've loaded the function under y1. So remember, under your alpha trace is where you can find y1. And type in the constant you want to evaluate the derivative at. So this is going to be the sine of 2. Any questions on how I type that in? And then when I hit enter, that's negative 2.173. Okay. Questions on that? Go to alpha. Hold on, I gotta look at it. Alpha trace. So now let's take a look at part B. Now they're giving us a completely different function, h of x. So h of x is defined as g of f of 2x. What rule am I going to have to use to calculate the h prime? Chain rule. It's going to actually be a double chain. Remember, start on the outside and work your way in. The function on the outside is g. So I'm going to take the derivative of g, which is g prime of f of 2x. Remember, that's the derivative of the outer. Times, work your way in. The next function is f. So I'm going to multiply it by f prime of 2x. Times, finally, I'm all the way inside. What am I going to multiply all this by? I'm going to multiply it by 2. So any questions on how I applied the chain rule there? So now it wants me to find h prime of 1.5. So I'm going to have to plug in 1.5 for x. So g prime, again, what's 2 times 1.5? 3 times f prime of 3 times 2. Well, I don't know what f is, but how the heck am I going to find f of 3? They gave it to us. Remember, they gave it to us in the very beginning. They told us that f of 3 was 2. So then I have g prime of 2 times f prime of 3 times 2. So where do I get f prime of 3 from? I get f prime of 3 from the what? From the equation. So remember, f prime of 3, I'm just going to simply plug into the equation that they gave me. Remember, they gave me f prime. So that's just going to be 3 times the cosine of e to the third. I'll dump that in my calculator. Where am I going to find g prime of 2? Table. So from my table, what is g prime of 2? G prime of 2 is what? Negative 3. Okay. So when I type this in my calculator, again, I've already got the equation under y1, so I can go to my second graph, save myself some time. So when x is 3, I end up at 0.986. So I type this all in, I should end up with approximately negative 5.916 or 915, depending upon your rounding. And we'll finish this problem together on Friday. Okay, we'll finish the last 2 parts. So your homework tonight is that 356 worksheet. And as you can see, it's just more practice doing chain rule, more practice of what we've been doing. So it's a good review. Everybody should have a copy of that Unit 3 test review.
Thank you.
That Unit 3 test review, it is optional. I'm not requiring you to turn it in. Remember, your test is going to be on Tuesday.